Okay, so let's look at a stationary box. So we have a person standing in here, light travels from one end to the other. This is going to be some distance L naught, and it takes some length of time T naught. Okay, T naught is obviously going to be L naught over C, because that's how light travels. So now let's consider what happens if the box is moving. So now the light travels here. By the time it gets to the front of the front of the box is there. So it gets a little further, front of the box is now over here. So it actually travels some distance d in this time. So d is going to be the distance that the light travels, that's c times t naught. Okay. Now, we also know, though, that someone standing outside is going to be measuring this with a different time. So this person's time is going to be the time that they measure. Okay, the time that they measured this to happen is going to be, the time they measure is going to be, well, the length of the box, L naught, plus how far the box went. So velocity times time divided by speed of light. Now, we also know from our time dilation arguments from before that T is gamma T naught. So if I plug that into here, we get the gamma T naught is equal to L naught plus V gamma T naught divided by C. Okay, divide through by T naught. So this is to be L naught over gamma plus V T naught over C. Multiply C T naught is equal to L naught over gamma plus V T naught. Okay, sorry, V T naught. Okay. But here's the problem. That's D. L naught over gamma plus V T naught. That's the L. That's the length of the thing. So D is the size of the object plus the velocity times time. So in other words, D is the length of the object plus velocity times time, but that length of the object is L naught over gamma. In other words, gamma, remember, is 1 divided by square root 1 minus v over c squared. Okay, and so 1 over gamma is going to be square root of 1 minus v over c squared. So that means that L is going to be square root 1 minus v over c squared times L naught. L naught is the size of the object if it's not moving. L is the size of the object if it is moving. So that's the distance right there if it's moving. So what that means is that the faster you go, as v gets bigger in there, then the square root gets smaller, so the distance gets shorter. So you might have a meter stick. If the meter stick's moving at close to the speed of light, it's not as long as a meter, it's shorter. And the faster it goes, the shorter it gets. So ultimately, if you were to reach the speed of light, the size of the object would have shrunk down to 0. In other words, an object moving at the speed of light is compressed down to 0 size. That means it's got 0 volume, because even if it has an area, it's got 0 depth in the direction of motion. So in the x direction, it's 0, so 0 volume. That means infinite density. Okay, now that gives you a problem. Infinite density. Remember, density is mass over volume. So if volume goes to 0, then the only way, infinite density is really bad. Okay, that would be infinite gravity. That would mean all kind of bad things happening. The only way this works would be if the mass is 0. Okay, and now you have 0 over 0. Then you go to L'Hopital's rule to figure out what is that. Okay, and that gives you a finite number. Okay, so that means the only thing that can go the speed of light is something that has no mass. Okay, so that means it ends up having 0 volume and no mass if it's going the speed of light. Photons, particles of light, go the speed of light. Therefore, they have no mass and they have 0 volume. Protons and electrons obviously have volume, they have mass, and therefore they cannot go the speed of light. If you try to go faster than light, look what happens. Look what happens to your dimension if you go faster than light. It's an imaginary number. That means your dimension, your spatial dimension, is now orthogonal to the universe. That means it's not part of the universe. If you're not part of the universe, you're never part of the universe. Science fiction writers have introduced the idea of tachyons, particles that travel faster than light. But the problem is they're not really part of the universe. They're not really things moving backwards in time, nor are they several other possibilities that were tossed out. But physically, no, they don't exist. Physically, they are not something that you would expect because, again, of that imaginary number that's right there. So this gives us the idea of length contraction. The faster you go, the shorter the distance, smaller something is. And again, it's by this gamma factor.